Okay, so for number 21, it gives you this equation f of t, which tells you is the fuel consumption of the car, which is in miles per gallon. So I have the fuel consumption here. They gave you this first equation. I did rewrite it as 1 over 20 times x, or s, minus 1 over 2400 s squared. That'll make it a little bit easier if we have to find the derivative. It tells you s is the speed, and speed is in miles per hour. It tells you that we have a car that is traveling at 50 miles per hour, so the s for the car is 50 miles per hour. And its speed is changing at a rate. So because it says that word rate, that means that's the derivative. So remember, this is a change of rates problems. If I want to do the derivative or the rate of speed, that means the derivative of speed with relationship to time, so ds over dt, and that is 20 miles per hour squared. Okay, we're trying to find the rate, so we're trying to find the derivative of the fuel consumption. So because we're trying to find the rate of f of t, that means that this is df over dt that we're trying to find. Alright, so that's what we're trying to find. We have speed and we have the derivative of speed. So I'm going to take my original equation f of t, and we need to find the derivative of it with respect to time. So the derivative of f of t will just be df over dt. And then I'm going to use the second equation I wrote to find the derivative. So remember, for derivatives of exponentials, you just write exactly what it is first. Like if you're doing the derivative of e to the x, it's just e to the x. We're going to write the whole thing first. Okay, then times, and then remember for exponentials you find the derivative of the exponent. So the derivative of 1 over 20s would just be 1 over 20. And then the derivative of the other part, well, you would do 2 times 1 over 2400. So 2 over 2400, and it'll just be s. And because we found the derivative of this whole thing, we're doing everything with respect to time, so you have to write ds over dt. So remember, related rates problem, every time you find the derivative, everything's with respect to time, so it's always over dt. So then we're trying to find df over dt. And we know that the speed, or s, is 50. So we're going to plug in 50 for s. And then we know ds over dt, which was our rate of the speed is changing, was 20. And then from here, you're just going to type all this in your calculator, or if it was calculator inactive, you would just leave it like that. And that's how I got the 4.299. Because this is the derivative of the fuel consumption, it told you fuel consumption was miles per gallon. But then that's with relationship to time, and time here has been in hours. So that's where they got the units from.